Hello, I am Mrs. O'Brien, and welcome to today's video on Section 13.2 Homework Questions 10, 12, and 13. Our first question, number 10, is a company will manufacture a tent that will have a square 15-foot by 15-foot base. So this base here is 15 by 15. 4 vertical walls, each 10 feet high, and a pyramid-shaped top made out of 4 triangular pieces of cloth. Its tallest point from this apex all the way down to this base of the tent is 15 feet. That means that we have 5 feet from here to here because there's 10 here, so it would be 5 more to get to the tippy top. So from here to here is 5, the height of the pyramid is 5, and then the height of the rectangular or square prism is 10. Draw a small version of a pattern for one of the 4 triangular pieces of cloth that will make the pyramid shape. So this is a little piece of the pyramid I've kind of picked off the top here and put over here. I just wanted to put some of the dimensions on it so you could see where they're coming from. We know that the side of the base here would be 15 feet because it's going to be the same as it is up here. Will be the same as it is up here, okay? So since it's a square base, all of those are 15 feet. So if I go halfway in, like I did here, that's going to be 7.5 because half of 15 is 7.5. We already talked about the fact that our height was 5 feet. What we don't know is the slant height, which we often call L. The slant height here we need to find by doing the Pythagorean theorem. So doing out the Pythagorean theorem, the L, or the slant height, is the hypotenuse of the right triangle. That means to find this, we have to do a squared plus b squared equals c squared. Since the longest side is always c, that's going to be our slant height L. And we solve this when we get approximately 9 feet. So if I look at what the triangle looks like for the pattern, I am going to have 4 of these to make the roof of my tent. And that slant height that was here, the 9.0139 feet, is this height of this triangle. So I'd be 4 triangles with a base of 15 and a height of 9.0139 feet. And that would be what the pattern would be that I'd have to cut out. So I'd have to cut out 4 of those. In our next problem, imagine a right pyramid with a square base like an Egyptian pyramid. Suppose that the sides of the square base are all 200 yards long, and the distance from each vertex of the base to the apex is 245 yards. So if I label this, I have the sides of the base are 200 yards, and then the edge here is 245. So if I take one of the faces off and kind of draw it over here, the other 245 for the sides of the triangular part, and the base of the triangle would be 200 yards. What I'd like to find is the height of the triangular face, which we call that height the slant height, or L. So again, I'm going to use the Pythagorean theorem. I've kind of dissected this little right triangle in here. Since it's an isosceles triangle, its altitude, or the height of the triangle, will bisect the base or meet it in the midpoint. So it's 100 yards from that vertex to the midpoint, because that's half of 200. So I've drawn this over here. So I have this little right triangle that is the image of this guy here. Now do a squared plus b squared equals c squared. In this one, the slant height is not the longest side of the right triangle. It's one of the legs. This guy over here, the 245, is the longest, so that has to go where C is. If I do this out, I end up with 223.6627 yards would be the height of each of those faces on that triangle. So now that I have that, I can use it to determine the surface area of the pyramid. We know what L is now. It's the 223.6627. We know to find the area of a triangle, it's 1/2 base times height. So if I go ahead and put in the base of 200 the height, which is my L, and divide by 2, I get 22,366.26925 square yards. So that's for one of the triangles, and there are 4 of those. So I would have to multiply by 4. So the pyramid is formed from 4 congruent isosceles triangles, and the area of each one of them was this. So just multiply by 4, and you'll get the area of the rest of them. And I did not do the square base because it said not including the base, so just wanted the lateral surface area. On the next one, we have a can, or a popular brand of soup comes in cans that are 2 5/8 inches in diameter and 3 3/4 inches tall. And each can has a paper label that covers the entire side of the can. And when you take that label off, you would get a rectangle. So it says if you remove a label from a soup can, you'll see that it's made of a rectangular piece of paper. How wide and how long would this be for this particular can? So the height of this cylinder is the same as this dimension here on the rectangle, or the label. So if it's 3 3/4 inches tall on the cylinder, it's 3 3/4 inches here on the rectangle. Now, if you envision this rectangle wrapped around the cylinder, the part around unravels to be this blue part. So the blue around the edge of the top becomes this dimension here. So since around a circle, the distance around a circle is called circumference, this distance here would be the circumference of our circle. So to find that, we are going to do circumference formula, which is equal to pi times diameter. So 2 5/8 inches times pi will give us approximately 8.25 inches. So that would be the dimension of this guy right here. It would be 3 3/4 inches by 8.25 inches, which I've written down here. You could have also left it in terms of pi. Part B wants us to, it says, ignoring the small fold and overlaps where the can is joined, determine how much metal sheet is needed to make the entire can. So this is really a surface area problem, part B. So we're going to dissect our can. We have our rectangular piece that makes up the outside of the can, and then we have the 2 circular pieces, which are the top and the bottom of the can. So to find the surface area of this, or how much metal it would take, we need to find the area of each of these 3 parts, the rectangle, and then both of these circles. The circles are congruent, so if we find just one of them, we can multiply by 2 and get the area of both of them together. So we already found the dimensions of this rectangle, so to find the area of it, we go length times width, or 3.75 times 8.25 gives us approximately 30.9375 square inches. And the area of each circle is pi r squared. So pi times the radius. Now, to get the radius, I just took the diameter that was given to me, 2 5/8, and I divided by 2, because the radius is half of the diameter. So that gave me 1.3125. Squared that, multiply by pi, you get approximately 5.4119 square inches. You'll need to double this because there's 2 of them. And then you add all of those areas together, and you get approximately 41.76 square inches. Thanks for watching. Images and questions from this screencast came from our textbook, Mathematics for Elementary Teachers with Activities by Beckman.